Welcome to Modifying Blanks. The past 2 days we've been working in the part screen. We are not going to be working in it today, but I do want you to familiarize yourself with all of the buttons and the layout of this window, because we are going to be working in a place that looks just like it. So let's close out of parts. I'm going to click on the fittings button, and I'm going to go into a job. I already have something in here. Let me just delete it. I'm going to add a new item. Just enter an elbow here. Now, from the fitting input window, I can go up to the top and I can click the flat pattern button. Let's just go to full screen here. And if we look in the upper left-hand corner, it says flat pattern view. Now, if you take a look around, there's not really too much you can do here. Most everything is grayed out. We can scroll through each blank. We can toggle one all. We can view all the blanks at one time if we choose to. This button right here is toggle preview. That will actually, this preview window right here, if we click the toggle preview, it will take that away. We can zoom in to a certain area, and as you can see, our snap icons, which we talked about yesterday, are enabled. The reason being is we can go to Data, select Measure, Distance. As you can see, I'm in Object Snap, and if I choose to, I can see how long this line is. It's 1 1/8 inch. Okay, but really that's about it. We're very limited on what we can do in flat pattern view. Now, let's close out of flat pattern view. The only way that you can get to flat pattern view is from the fitting input. The reason being is because each time you click this OK button, we recalculate the fitting. So if we were to allow you to make any kind of modifications to a blank, those modifications would be lost once you select the OK button. If you do want to make a modification, check the Modify box, then click the OK button. You'll get this dialog box. Do you want to modify these blanks now? We'll say yes. And now if you look in the upper left-hand corner, it says Flat Pattern Modify. And with exception of a few buttons, all the buttons are enabled. Okay? So take a look around. This is basically parts. We do have some new buttons. Let's start in the upper left corner here. We still have our object usage buttons, which is cut object and scribe object, but now we have a new segment object button. Below that, in our, and actually I've made some adjustments here. Let me reset my layout. Okay, we still have our draw tools. We have line, arc, circle, rectangle, and slot, but now we have two new buttons, circular hole and rectangular hole. At the top, again, we can scroll through each blank. Then we have our segment buttons. We have segment blank, clear segment, and start over. Again, we can view all the blanks if we choose to. And that is about it. We do have some cut path review buttons, but we'll go over that in a different class. So let's go back to blank number 1. And let's look at our new circular hole and rectangular hole. But before we do that, let's bring up the circle. Remember, with the circle, you can enter a diameter or a radius. with the new circular hole button, you can still enter a diameter or a radius. If you enter something in both fields, it's going to go with the diameter or the first field. But below that, we have two new fields. We have X raw edge offset and Y raw edge offset. As you can see, it's already pre-populated with some values there. What that is the very center of this blank minus any seams and connectors. So what I'm going to do, just hit cancel here. And now, depending on my allowances, this might be a little off, but basically, this blank minus any seam and connector, I'm drawing a square here, that is the center of my blank. So let's go back to the circular hole. Let's say I want to place a 1-inch diameter hole in the very center of my blank. Okay? Now, I could choose an offset corner, upper left, upper right, lower left, lower right, but since it's in the very center, it doesn't matter. So I'm just going to say OK to this. Places a hole in the very center. So I've got a square here that's kind of blocked out my blank. Let me just draw a little X here. And as you can see, it's placing that hole in the very center of my blank. Okay, let's delete that. We'll go back to circular hole. Okay, now like I said, you can place this from any corner. Now yesterday we talked about the different input methods, relative, absolute, and polar. You do not have to use any one of those three input methods. Now what I mean by that, let's say we want to place this from the upper right. As you can see, we're in relative. So if we want to go from the upper right corner, if we would have to place a hole to the left and down. Normally in relative, you would have to enter negative values. But with this new X raw edge offset, you don't have to do that. So let's say, and remember, again, this is minus any seam and connector. So it's the finished dimension of the fitting. So from the upper right corner, let's say we want to place this 5 inches over and, I don't know, 8 inches down. We'll say OK. And from this point, not out here, from this point right here, it's going 5 inches over and 8 inches down, and it's placing that hole based off of the center point. Okay, we'll just save that. We'll go to the next blank. Now, before we look at the rectangular hole, let's take a look at the rectangle tool. We can enter a width, a height, and an optional corner radius. Let's close out of here. Let's look at the rectangular hole. With the rectangular hole, again, we can enter a width, a height, an optional corner radius, and now we have an option to enter it at an angle. Again, we have the X and Y raw edge offset, and you can place it from any one of the four corners. So let's say we want a 2x4 with a 1/4 inch corner radius at 45 degrees, and we're going to place it in the very center. Okay, again, it doesn't matter which corner, since we're going in the very center, that we choose. It's still going to place it in the center. Okay? At this point, we could save and exit. We'll close out of here. We can process our job and go into sheet review. And as you can see, it's kept those changes. Okay. Okay, so we've gone into flat pattern, and I've shown you how to place a hole using the new circular and rectangular hole buttons. But when talking about modifying a fitting, there's basically three different types of modifications. You can place a hole into any blank, you can modify the perimeter, and you can segment. Okay? So we've already looked at placing a hole. Well, actually, there is one other thing that I want to show you. Let's go to another blank. And this got brought up in one of my classes. Somebody was asking me if we were going to add the slot and have it use the X and Y raw edge offset. I do not see this being added anytime soon, so I'm not sure if we're even going to add it. But one thing that I did say that they could do is, because they liked it being placed in the very center. Well, you could place a circle, go to Markers, Mark Object, click on the object, and then enter the dimensions for your slot. Okay, I'm going to switch to Marker Snap. I can snap onto that marker and then delete the original circle. Okay, so that's something that you can do as a workaround. Again, I don't know if they're going to add that to it. I've added it as a wish list, but because you can place it so easily using the circular or rectangular hole button, I really don't know if they're going to add that. So anyway, I just thought I'd show you guys that. Okay, so now let's talk about modifying the perimeter. And I'm going to enter a transition. Okay, again, you can check the modify box before you click the OK button. But let's say you don't want to modify it right now. You might want to go back later and modify it. So I'm just going to say OK to this. I can close out of my Fitting Select screen. The other way to get into Flat Pattern Modify, from the grid, highlight your fitting, and you can either click the Flat Pattern button, or you can right-click on the highlighted fitting and select Flat Pattern. Either way will take you into Flat Pattern Modify. Okay, let's talk about modifying perimeters. I've entered a transition, and I'm just going to show you a couple of different ways that we can modify the perimeter. One way, we can select Edit and go to Parallel. Well, actually, before we do that, let's go to Data, Measure, Distance. As you can see, I'm in Object Snap. I want to measure from the end of this line to the beginning. Okay, so we can see that it's 1 1/8 inch. So let's say that there was, for some reason, we need to extend this another inch. We could do that very easily by going to Edit, Parallel. We'll give this a 1 inch offset. Remember, when using parallel, just select the line that you'd like to parallel, and then depending on which side of the line you click, you can either parallel it up or parallel it down. I can then hit Delete, go to Edit, select Trim and Extend. I want to extend this line up to this point. Okay, so that's one way that we can modify the perimeter, extending that that joint. Another way we can extend it, we can go to Edit and Move Vertex. Remember, vertex is just a fancy word for a corner. I'll select the corner that I'd like to move, and then on my keyboard, all I need to do is type 0 for my X, because I'm in relative, and -1, oh, I'm sorry, I didn't hit Enter, and -1 for my Y. I can go to the other side, 0 on my X, and -1 on my Y. Okay, so that's another way that we can modify the perimeter. Let's go to our next blank. We'll zoom into the top here. Another way that we can modify the perimeter, we can use Fillet. We can either radius or chamfer the corner. We'll give this a actually a 1/2 inch radius. Remember, when radiusing corners, all you need to do is select the 2 lines that make up the corner. Go back again. We can put a chamfer on the other end. Really, I don't know why we would want to do this to this fitting, but we're doing it anyway because we can. Okay. Another thing we can do, snip. Remember, snip is like having a virtual pair of 10 snips. The first marker is going to be placed on the outside, the second one's on the inside, and the third one's on the outside. Okay? You could also do that to the corner. Oh, left a little line there. Let me hit escape. The reason why it did that, let me hit drag. Depending on how your connector is set up, you see that I'm dragging one line at a time, and because my connector is set up, I guess in 2 parts, it only grabs, or it's only it's not touching this one when I hit the snip. Okay, so in that case, what I would want to do, let's go to Edit, Snip again. Okay, so in that case, what you would have to do is delete the extra line, or it will cause problems when you go to try to cut it out. Okay, so those are some different ways that we can modify the perimeter of a blank. We can hit Save and Exit, process our job, and as you can see, it's going to be this blank. As you can see, it's saving all of the modifications that we made. Okay, next we're going to talk about segmenting. Segmenting is basically a 2-step process. First one, draw the segmenting line or arc, and the second step to actually perform the segmenting itself. Okay? So first what I want to do, I want to show you how to manually segment. I'm going to select New Item or Blank. Okay, and normally segmenting is associated with an oversized fitting, but that is not the case. It does not have to be oversized. You can segment any fitting at any time. Okay, so I'm going to enter this radius throat, radius heel, elbow. I'll click Modify, say OK. Yes, I want to modify these blanks now, and as you see, it throws us into Flat Pattern Modify. Now, the other day when we were going through our draw tools, we came to radial arc, and I said that I was going to talk about it in another class. Well, this is that class. When you select radial arc, it's going to ask you for a division. We're going to give this a division of 3. I'll say OK to that. Now, what we need to do, because we want to segment this, we need to select the Segment Object button. Okay? Remember, yesterday I told you that you need to always be aware of which input method, which snap icon, and which object usage icon you're using, because it's going to make the program act very differently. So we need to make sure that we have segment object selected. And when using radial arc, you always want to select the outermost radius, because what it's going to do, it's going to draw the lines to the center point of the radius. Okay, so we'll click the outermost radius. As you can see, it's dividing my radius into 3 equal sections. If you're not sure what that red color means, remember you can always go to View, Options, click on the Colors tab. Right now we're working under regular shapes, and it's telling us that red line is a segment line. Okay? At this point, we can now click the Segment Blank button. It applies our segmenting seam. And after you segment a fitting, you always want to scroll through and make sure that each blank looks the way you think that it should look. Okay, now it brings us to blank number 2. Again, all we have to do is go to Draw, Radial Arc, give it a division of 3, and if you did not click the outermost radius, if you click the innermost radius, as you can see, it's going to the center point, but our segment lines are not placed on our blank, so it's not going to do anything. So let's delete those. So remember, anytime you use Radial Arc, you always want to click the outermost radius. We'll then click the Segment Blank button. Scroll through and look at those blanks. It's always a good habit to get into. Once you're complete, hit Save and Exit. Now, you might be wondering, where do I get my segmenting seam from? Let's go back into the fitting input. This segmenting drop-down is where you get your segmenting seam from. Okay? Now, one thing that I do want to point out is our OK button is yellow. That's a cautionary color. Remember when we first started the class, I told you each time you click the OK button, we recalculate the fitting. And if you made any modifications, they're going to be lost. That's what that's telling you. If you click that OK button right now, all your modifications are going to be lost. What you can do, you can click the Cancel button. Let's process our job. We'll go into Sheet Review. As you can see, my elbow is still cut up into, segmented into 3 sections. But let's go back in here, and I'm going to click the OK button. I'm going to uncheck Modify. I'll just click the OK button, and you'll get this warning. If you continue, all modifications to this fitting will be lost. Now, there is a little box here that says, don't show this message again. I do not suggest that you check it. If you check that, you will never get this warning again. It's really up to you, but again, I don't suggest you check that box. I'll just say OK to this. We'll go back, process our job, go into Sheet Review, and as you can see, my modifications are gone. Okay. Now, I still have it on my other fittings. If you look right here, that's where I snipped it and radiused and chamfered the corner because I did not re-OK that fitting. I just re-OK'd my radius throat, radius hill, elbow. Okay, so let's close out of here. Let's talk about oversized fittings for a second. I'm going to go into New Item or Blank, and I'm going to put in the same radius throat, radius hill, elbow, except for this time I'm going to give it some oversized dimensions. I'll say OK to that. And now, when you enter an oversized fitting, you'll get this oversized fitting window. It says this fitting is oversized and needs to be segmented. You've got a couple of choices here. Under Segmenting Method, you can choose to cut the blank in half or multiple full sheets. Now, the difference between these two methods, when you choose to cut the blank in half, you're going to get a more symmetrical looking fitting. When you choose multiple full sheet, you're going to have a better material usage, but sometimes it looks like the fittings are kind of Frankenstein together. Okay? You can always choose Manual. That's going to throw you into Flat Pattern Modify, and you can manually segment it. If you think that this fitting should not be oversized, maybe you've entered some wrong dimensions or you're using the wrong type of, the wrong gauge of metal, you can always return to the fitting and make those changes. And there's this automatic breakup section, which we're going to talk about in just a little while. So let's choose Manual. Again, that's going to throw us into Flat Pattern Modify. It's already applied some segmenting. I believe this is, if it cannot cut the blank in half, it will automatically use multiple full sheet. Since this fitting is so large, it has to use multiple full sheet. But as you can see, it's a very ugly segment. So what we're going to do, I'm going to come up to the top. I'm going to click the Start Over button. That's going to take away all of my segmenting. I'll then go to Draw, select Radial Arc, and we're going to give this we'll try a division of 6. Again, okay, one thing that I do want to point out, if you look over to the left-hand side, I have not selected the Segment Object button, but it's automatically been selected for me because the fitting is oversized. You'll find that the program is somewhat intuitive depending on what functions you're doing, or in this case, if we enter an oversized fitting, when we go into flat pattern, it knows that it's oversized, so it's automatically going to select the Segment Object button for us. Okay, so that's just kind of a convenience. Let's go to Draw, Radial Arc. We'll give it a division of 6. I'll select the outermost radius. We can then hit the Segment Blank button. As you can see, it has applied the segmenting. Again, you always want to get into a practice of going through and looking at each blank and making sure that the segmenting seam is applied properly. Because when you're talking about a segmented fitting, I mean, you're talking about a lot of money that's getting tied up into a fitting. For one thing, because it's so big that it needs to be segmented. But another thing, it's being segmented, so somebody's going to have to put that much more time into it to put all those pieces together. So let's go through. We're going to look at each blank. Okay, now watch what happens when I go to the mirrored cheek. I did not have to go back into Radial Arc and resegment this. Now, currently, this is something that is only done for oversized fittings. Okay, we're automatically going to mirror segment the opposing cheek. Right. I have put a wish list in because a lot of people have asked for this to the programmers to do this for all fittings. It doesn't matter if you segment one cheek to automatically mirror segment the opposing cheek for any fitting, even if it's not oversized. But again, currently this is only for oversized fittings. Even though that it's segmented that, again, just I want you to get in the habit of looking through each blank and making sure that everything looks good. If everything looks great, hit Save and Exit. Okay. Still on segmented fittings, I'm going to enter an offset. Make this 200, 100-inch offset. Okay, now, what we need to do is, as you can see, my seam is a half lap. The bottom, I'm going to use TDC, and the top, I will select Slip and Drive. I'm going to say OK to this, and we can choose to cut the blank in half, multiple full sheet. We can manually segment it. But what I'm going to do, I'm going to select Automatic Breakup. It's asking for a type of connector. I'm going to say welded. And then I'm going to click the Attempt Automatic Breakup. I'm going to get this breakup radius form. Here, you can select the duct style. We're going to leave it at L-shaped. You can enter an elbow throat radius. 9's fine. A minimum elbow throat. We'll leave that at 3. A default duct length. And then a minimum duct length. We're going to change that minimum to 6. So that means anything under 6 inches we will not produce. Okay, we're going to say OK to this. And when I go back, instead of adding an offset, and I'm just going to delete the previous fittings that we entered. Instead of adding one oversized offset, what it's done, it's automatically broken that up, as you can see, a quantity of 3 right here, into these 6 separate fittings. So what we're going to do, let's go into the non-90 elbow first. As you can see, it's using the 1/2-inch lap seam that I specified on the offset. This connector is a slip and drive, which tells me when I pull up the other non-90, it's going to be TDC. The connector that connects my non-90s with my standard duct and my other non-90 elbow is all going to be welded, as we can see right here. Let's close out of here. Let's go into the other non-90. As you can see, it's still using the 1/2 lap and the TDC on this one. Okay, it's got the weld seam. Let's see. And actually, I'm sorry, I forgot exactly what it said on the breakup radius form, but here is our 9-inch throat, and here is our 3 inches of straight that we specified. Now, when I go into my standard duct, it should be L-shaped, which it is. It's using a 1/2 lap. It's using a welded seam. A welded connector, and the same should be for the cut duct. Okay? And it's making that. Now remember, I said anything under 6 inches it will not produce. So this was 19 inches, so it produced it. Now let's go back and enter the same thing, except for we're going to change one thing, and this is really cool. Okay, that was 20 by 20, 200 by 100. Let's see, I believe I had this at slip and drive. We'll say OK to this. We'll select weld. We'll click attempt automatic breakup. Now, what I'm going to do, I'm going to change my minimum duct length to 60. Okay? It's matching my default duct length. I'll say OK to this. Now, instead of having 6 fittings, we now have 5. It's taken away that piece of cut duct. Okay, but where did it put it? Let's go into our non-90s, and now instead of having 3 inches of straight like I specified before, I now have 12.592. So it's taken that 19-inch piece of cut duct, it's divided it up, and it's added it to my non-90s. Okay? Okay, so that is pretty much it for automatic breakup. Let me look at my notes real quick. There is one thing that I did want to show you. Let's go into, and for this, I need to go back into parts. I've created this this angle clock, and I meant to show you guys this yesterday. Every now and then, when you're working in either parts or flat pattern, you're going to select data, object. You'll click on a line, and it's going to give you an angle that that you might think is wrong. Okay, and what I mean by that, let me reset my tools here. Let me select my line tool. I'm going to switch to free pick. I'm going to draw a line from the center of this clock to about right here. And we can all agree that this is pretty much 45 degrees. Let's go to data, select object. I'll click on my line. As you can see, it's 45.3 degrees. Okay? Now, I'm going to select markers, mark object. I'll give this a division of 2. I'm going to delete my line, and I'm going to redraw it. But instead of going from the center out, I'm going to go out to the center. I'll then go to Data, Object, click on my line, and instead of being 45 degrees, it's now 225 degrees. The reason for that, it's 180 degrees off from what you think it should be. The reason for that, if we drag, it's all based off of the start point. My first line, I started at the center of my clock and went out. So if we drag my start point to the center of my clock, as you can see now, it falls at about 225 degrees. Okay? So if you're ever using Data Object and you get an angle that is 180 degrees off, that's the reason why. Because it's not starting where you think that it's starting. It's starting on the other end. Okay? Does that make sense to everybody? Great, great. Okay, that's it for me today.